Hi there. This is Block Scraper for Web3 Builders Alliance Solana Cohort Capstone project. The Block Scraper is a Web3 Solana analytics tool initially designed for refi, or known as regenerative finance. However, it was decided that it can be scaled further up to the limit to have all the DeFi ecosystem available. The problems between the Web3 analytics ecosystem is that one, most Web3 analytics firms are actually focused on financial and research analytics, and they solely have on-chain data. Or most of the people are like work with big data, like DAppRadar, who actually provides research analytics and little to no insights when it comes to marketing and product analytics. In order to solve the video, and this video will contain the code review for the Block Scraper project. This aim will create a walkthrough by using code review, and it will help you understand the whole aspect of the project. Initially, the web scraping and the bundler packages have been built as independent, and they don't really go along with each other due to the Solana's technical limitations. For web scraping, they decide to create both TXT and PNG file, and I've uploaded the PNG file because I don't know whether TXT files could be uploaded by using bundler. And as you can see, which we decided to create a demonstration purposes known as the refi PNG, and we decided to use Selenium for our web scraping purposes. In short, Selenium is actually a web automation tool that can be used with web scraping alongside with many libraries such as Beautiful Soup 4, Scrapey, and other known libraries around the world. And in this video, we have imported WebDriver. After importing WebDriver from Selenium WebDriver, we use the Chrome service to import the services, WebDriver Manager to Chrome Driver Manager. We imported keys, and we imported by, which are Selenium libraries and applications built on other stuff. In driver, which we designated our WebDriver as Chrome, and we decided to install it thanks to the Selenium 4 and the most recent updates. We don't have to download external files to install the Chrome driver, which was actually known to be a really annoying task. In the driver.kits, we decided that it was google.com, which we chose by finding the elements by name, value, and we sent the keywords regenerative finance Solana. In this here, we wanted to get an overview of the financial refi ecosystem on Solana, and we decide to enter the keys, and then we maximize the video to get the picture in a more accurate manner, and then we decide to save the screenshot to a driver. On the other hand, which is to further support our web scraping efforts as potential users, we consider using web scraping tools to analyze the products, the projects, and also to work as a marketing analytics for sentiment analysis purposes. Like similar to the PNG version, we imported WebDriver, we import service, WebDriver weights. WebDriver weight is actually being used to make the web scraping more appropriate, because in websites, if you have too much traffic, they can be actually detected easily, and you actually have a problem that the websites can actually block your IP and you get blacklisted. From WebDriver, we imported expected conditions, And we imported beautiful soup, which we decide to use it to pass down the HTML files. Also, the dynamic web script sites, which really works with. And then we decide the regular expression codecs and the Chrome Driver Manager, which are common tools for web scraping tools. In this code, we first initially installed the Chrome Driver Manager, and then we required the user to enter an URL. And after each search, we decide to make the WebDriver wait for 10 seconds. We make them wait for a while because we don't want to hurt their websites, or we don't want to get blacklisted, and we're trying to be compliant as much as possible to robots.txt. We get the value, we get the URL, and we wait until the expected conditions URL to be equals to a value. If we get the URL, and then we get the page driver page source, and then we start to pass the HTML in order to have meaningful insights with the beautiful soup library. And in order to make our search more specific, we want them to enter a keyword to find instances of in the article. We actually ask them to have enter a keyword in order to find them, and then we match them by using the soup.butterfly.findAll. And now within the function, we say the regular expression.compile the keywords, and then if the length of the match matches with length, and the title is the soup.title.text, which is the text title of the soup, which we decide to name our file, and it creates a file for us. It opens the file, it writes a file with titles, and in the file, it states whether the keywords are used or not for each time. And in matches, we want them to write the file, the count of as a string, whether they have dots or the I values or the other values that like hash tags. As soon as we did write with them, and if we follow with all of the code in Selenium, which is a bit more difficult compared to other things like Scraper, which requires you to have a valid URL. After having a valid URL, you need to have a substring, and now you need to choose a keyword, which it's known to be a bit of lengthy process. We write the file, whether we found them in the keywords, we close the file and we quit the file. And this is actually for demonstration purposes. We are actually demonstrating the web scraping tools. For the later phases, we are going to, for web scraping, for later phases, we are planning to expand and crawl and scrape many more sites at once, actually scraping the whole ecosystem. Then we are going to create web scraping tools for product analytics, which are much more developed, giving much more detailed insights. And also, we are planning to do it on an automated scale, which will further help our operations. On the second part of the Solana, the storage type, which is bundler, in order to provide a much more simplistic view, which we use bundler for storage on the blockchain. However, I would like to tell you from the very first times that the whole project is here for the demonstration purposes, and we decide to import bundler, decide to import the fs.tmv. We configured it, and then we configure the fs, and we decide to file to upload, which we decide to upload demo in order to show that we can actually use Solana in bundler, which is all for demonstration purposes. and then we are connected to Node to wallet, the file size, and the price is being converted to Sol, funding the transaction, funding the node, and uploading it, which is a error catching, try and catch situation. We are looking for a response. If we get it, the file is uploaded to Arweave, which bundle uses Arweave both, and it makes it stored on both Solana blockchain and Ethereum blockchain. And then if you fail it, the error is upload. We have an issue uploading the file, and it gives us the error message. Okay, for later phases, which this is the V1. V1 is purely for demonstration purposes. For V2, we are actually planning to build web scraping tools for marketing and product analytics purposes, which they will have much more comprehensive tooling. They will scrape the web, more compliant with the robust.txt files. We'll have as many sites as we can, and then expanding the upgrade after we've succeeded in capturing the ReFi ecosystem on both marketing and product analytics. We are planning to go onto on-chain sources with minimal tooling like Helios and other Solana tools, and then we are planning to expand it to all the networks, including all the Near Protocol, Ethereum, BNB chain, and many more networks to capture the analytics. And we are actually working on to bring cloud solutions on the blockchain by using Google Cloud Platform. Thank you for watching, and I'm waiting for all the feedback.